Welcome to the Crazy Hat Chemist. So another video here on acids, bases, and titrations. Let's get moving. This is part B of example titration problem number 3. So let's get moving. Bam! So halfway or midway point calculation of acetic acid and sodium hydroxide. Now make sure that you refer back to the first video. That is titration example number 3, part A, because part A has all the initial parts of this problem, and you need that in order to solve this problem here. So the same equation applies to the point before titration, okay, with the ice table that we used, okay? However, at this point, what's important is that the concentration of the conjugate pairs are equivalent at the halfway or the midway point. Okay, so this is the same equation that we use at the beginning initial point in the pH of the titration. Okay, that is acetic acid plus water produces the acetate ion and hydronium ion. So what's important here is that the concentration of the conjugate pairs are equivalent. Okay, so that is the acetic acid and the acetate ion, their concentrations are equivalent. So we need to write the Ka expression for this. Okay, the acid dissociation constant. Okay, which is the products over reactants with the stoichiometric coefficients as exponents, and of course solids and liquids are not included in any K expression. So therefore our K expression is Ka is equal to the acetate ion times the hydronium ion concentration, those are both in the numerator, divided by the acetic acid. Okay, now concentration of conjugate pairs are equivalent. So what are we going to do with those? Since they are the same, whatever value they are the same, and we're going to cross them out. So what do we have left when we simplify this? We have the Ka is equal to the hydronium ion concentration. Super simple. Now what we need to do is plug into this. Okay, we have the Ka initially on this problem of acetic acid. That's 1.8 times 10 to the negative 5. That's equal to the hydronium ion concentration. So what am I going to do to get the pH? Take the negative log of the hydronium ion concentration. Now I'm going to get the pH. So negative log of hydronium ion concentration. I'm going to get that value, and that's going to be a pH of 4.74. Okay, remember, at this halfway or midway point, the pH is equal to the pKa. The pH is equal to the pKa at the halfway or the midway point. Now, you should ask yourself, does this value of 4.74 make sense? Remember the graphic that we drew out initially on part A of this particular problem. Okay, that was in the buffer region. This is right in the middle of the buffer region of acetic acid and acetate ion. This is when the concentration of the conjugate pairs are equivalent. And of course, we've only added a little bit of the base. The base has been consumed by the by the acetic acid and produced acetate ion. And so therefore, this is mathematically the halfway or the midway point. Okay, and the pH is equivalent to the pKa. And that value is acidic, and that should make sense. Okay, of course, and that's what you would predict. I am the Crazy Hat Chemist, and of course, I can't leave this here without doing a crazy hat. And again, this is the iconic hat here. So give me a thumbs up if you like that video. Subscribe to my YouTube channel. Donate to my website. Get a sticker. See you later for next time. Bye for now.